tolerant, how tolerant of the sembada merah. Usually in the case of production, seems like rice, like seems like that. Usually we use the seems like 50% yield decrease if the salinity seems like 10 or something like that. But I didn't get this information from your presentations like that. Rice, like, seems like thank you very much. Usually we use the like 50% yield decrease if the salinity.
Okay, I want this time for me to try to answer your question. Okay, the first, why we use calcium silicate? In all our study, we try some source of silicon as a beneficial element. I try source of silicon element from rice husks, so from volcanic ash, also sodium silicate, calcium silicate. So in this presentation, I want present the synthetic silicate. So when I think in market, is this there are no fertilizer. So I use in biology, we know I think it's the silicate fertilizer have an alternative if they're possible to reduce the effect of salinity. So in this study, I use synthetic silicate fertilizer, calcium silicate from Sigma. I think that's pure from factory. So, and the next question about sembada merah. Sembada merah is, as we know that sembada merah is sensitive to salinity. To say that 10 decisimen per meter is high salinity stress. So we want to know, when we apply the calcium silicate until the salinity stress that can this cultivar that can tolerant to this salinity. So we analyze based on physiological. So in the last year, we present about the growth of this rice and also the oxidative defense response of the rice. Because I come from Faculty of Biology, so we study about the mechanism of this plant to tolerant in this condition, in this case, to salinity stress. So I also determine how about the condition of the root, because if a plant absorb the silicon, it will deposit into exodermis and endodermis to reduce the apoplast transport, so can reduce the transport of sodium into the stele, so can reduce the negative effect of salinity in the whole plant. This is my answer. I think it's enough. Or
I want ask, May?
Yes.
Okay. Because we limited by time, maybe we continue to the next presentation. We can discuss maybe in after this.
I think we can chat.
Okay.
Oh yeah, thank you, Bu. I will do it. Yeah.
Thank you very much. Personally, communication is okay. I think we will collaborative with another people from other university or other institution. I will join the collaboration research, I think. Thank you.
Thank you, Ibu Dia. You're interested.
Okay, thank you very much, Mrs. Dia. Actually, very interesting, but the time is over. Okay, the next presentation is Mrs. Ainuniswati. The title change in soil available phosphor and nutrient uptake by maize following the application of wastewater acidulated phosphate rock.
Good
Okay.
afternoon, everyone.
The title
I'm Aina
change
Miswati from
in
Lampung
soil
University.
available phosphor and
Thank you
nutrient
for
uptake
Mr.
by
Chairman and thank you
maize
for the
following the
committee.
application of
I would like
wastewater
to
acidulated
present
phosphate
our
rock.
research result with entitled is a change in soil
Okay.
available
The
phosphorus and
title
nutrient
change
uptake by
in
maize
soil
following the
available
application of
phosphor and
wastewater
nutrient
for Mr.
uptake by
Chairman and thank you
maize
for the
following the
committee.
application.
Solubility. For produce a phosphor fertilizer, we have to acidulate the phosphate rock with a acid strong like phosphoric and sulfate acid. In Lampung, there are many agro-industrial wastewater, for example, for tofu and tapioca. Utilization of agro-industrial wastewater can reduce environmental pollution and emission of greenhouse gases into the atmosphere. One of them is by utilizing its agro-industrial wastewater for dissolved PR because of agro-industrial wastewater have a low pH. After that, the phosphate rock hop with high solubility. Objective of the research is to determine the effect of tofu and tapioca wastewater acidulated phosphate rock on soil availability P, soil pH, and NP uptake, dry shoot biomass, and grain yield of maize. This is a potency of agri-industrial wastewater in Lampung province. Tofu wastewater and tapioca wastewater. Location of the research is in a research station of Assessment Institute for Agricultural Technology of Lampung in dry season of 2017 with ultisol soil with a low pH and low soil availability with a sandy clay loam texture, and phosphate rock we use has pH around 7.72, total P 25.09%, and soluble P 6.8%. With a wastewater tofu and wastewater of tapioca with a low pH, and this is a GOD and BOD, and total P very low, and total N also very low. This is a location of the field experiment in Desa Negara Ratu Natar, South Lampung. Phosphate rock acidulation by wastewater tofu and tapioca before treatment with mixed incubated and shake, incubated for 7 days, and after that drying and ready for use. Experimental treatments were run with split plot in randomized block design with 3 replication. The main plot is tapioca wastewater and tofu wastewater, and the subplot is dosage of phosphate rock. This is from control and until high doses, there are 7 treatments from P0 to P6. Field sampling and analysis for nutrient uptake, we sampling at a vegetative maximum stage of the maize plant, and for other is in harvest time, and data analyzed by ANOVA and BNT. Result, this is a table of soil available P, soil pH, and P uptake by maize dry biomass and green yields, and this is a summary of the ANOVA. Agricultural wastewater is not significantly different for available soil P, soil pH, and uptake, P uptake, soil biomass, and grain yield. But dosage of acidulated PR has a significant effect on available soil P and uptake, P uptake, and for green yield. It has no significant effect on soil pH and forsooth biomass. There are no interaction effect between wastewater and dosage of PR for all treatment, for all observations, except for soil P availability. This is an interaction effect of wastewater, acidulated phosphate rock, and kind of wastewater on soil available P. Phosphate rock was acidulated by tofu wastewater. The acidulated PR was significantly increasing available soil P. Start from the lower dosage of 350 kilogram per hectare acidulated phosphate rock. In addition, original phosphate rock without acidulated with the dosage of 500 kilogram was significantly lower than tofu acidulated PR for all treatment, except there were outlier data of P7, P5. The acidity of an organic solvent will affect the solubility of P, and the available soil P increases. This is a figure of change in N and P uptake by mice following the application of different dosage of acidulated PR. They were not significantly different of acidulated PR from of all dosage for N uptake by mice, except for the highest dosage of acidulated PR, 950 kilogram per hectare, in which there are significantly different with both unacidulated PR, 500 kilogram per hectare, and control. The increasing dosage of acidulated phosphate rock was not significantly different in increasing P uptake by mice compared to the control. The higher the P dissolved in the soil, the higher the P nutrient uptake. The higher solubility of P will facilitate the N uptake by mice. So, this is interaction effect of wastewater acidulated phosphate rock and kind of wastewater on the green yield of mice. In wastewater of tofu acidulated phosphate rock, the dosage of acidulated phosphate rock increase following the doses. But for acidulated by wastewater of tapioca, the dosage no difference, no increasing significantly for the green yield. But compare tofu wastewater and tapioca wastewater, it's better tapioca wastewater for the green yield of mice. Conclusions. Application of tapioca and tofu wastewater for acidulation phosphorus in phosphate rock can be used as alternative for increasing solubility of phosphate rock fertilizer before applied in the maize plantation in the field, because it can be increasing availability of soil phosphate. Nutrient uptake will be increased if acidulated phosphate rock were applied with higher doses. Tapioca wastewater is better than tofu wastewater for increasing maize production via acidulation phosphate rock. This is a reference, some references, and thank you very much for your attention. That's all. Thank you.
Okay, thank you, Mrs. Ainin. Any question?
Boleh,
Mrs. Ainin?
Arianto.
Yes.
Yeah. Oh, Mrs. No.
Yeah.
Okay,
Thank you.
please.
Thank you, Pak Arianto, as moderator. Prof. Ainin, very interesting. Interested your title. Why not share optimum dosage to every weight water acidulated? And number two, what's the type of rock phosphat? May you explain? Because the rock phosphat in Indonesia very abundant. Okay, please. Thank you.
Okay, thank you. Please, Mrs. Ainin,
Yes,
respond the question.
thank you very much for Ibu Dr. Nunung Sondari for your questions. Your question is why I didn't find out the optimum dosage of rock phosphate. Previously, I looking for the dosage optimum dosage. So we design the treatment from 0 to 950 kilogram per hectare. In our mind, I have to find out the optimum dosage. But for phosphor, there is a maximum or optimum uptake from the soil because phosphor there are residue in soil. If I apply high doses, the nutrient uptake limited because of the capacity of maize is limited. So the phosphate rock or maybe inorganic fertilizer like SP36 or TSP also make a residue in soil. So there are, I think this from this treatment, I find in the high doses in 950, it is not difference. So I think it's optimum only for around if you look at table in green yield, this from P5 is 650 kilogram and 800 and 950 it is the same. This optimum for the green. I think this from phosphate rock in 650 kilogram. Yes, and rock phosphate the prefer study in Lampung in middle of Lampung in Lampung center of Lampung there are amount of rock phosphate. When we sample in the first time, the P, the phosphate total and phosphate solubility in this rock phosphate higher. But after that, when we analyze this again and again, the
How
P
much
content
percent, Bu? How much percent content of
12 12%.
rock?
But after that, it's lower. Then for this experiment for this season, I use rock phosphate from import from Egypt. So with the content about sorry I forget in there, but 14%, yeah, 12 until 14%. Yeah.
Okay. Thank you.
So yeah. Thank you. You're welcome.
Thank you, Prof. Ainin.
Yeah. Is there any other question?
Okay, any question again? If not, maybe we continue to next presenter. Thank you, Mrs. Ainin.
Yeah.
Thank you, Mrs. Nuno.
Ya, thanks again Pak Dwi. Terima kasih.
Okay, the next presenter is Erma Fitriarini.
Yes.
Okay, there. Okay.
Everyone, let me introduce myself first. I am Erma Fitriarini. I represent my team, Dr. Paramita Rahayu and Ms. Hakimatul Mukaroma. We are from Urban Planning Program and also part of study center called Regional Development Information Center at Universitas 11 Maret. Thank you for the opportunity. This time I will present our paper based on our research titled Mapping Land Use and Surface Water Quality for Urban Clean Water Resource. This research is based on the issues happen in our urban areas, like what UN said. The world's population living in urban areas is now predicted to increase from 55% in 2018 to 60% in 2030. We also facing a rapid urbanization which has triggered the government to meet various community needs, especially basic needs and food sources. Unfortunately, natural resources to fulfill that needs, including water, have been affected by climate change. So the population growth, water needs cumulated with climate change will aggravate the global water scarcity crisis. The quantity and ease of access to water needs is not equal to the availability of abundant resources of clean water, which nowadays arise the needs of alternative water resources. Surakarta also faces water supply problems primarily related to raw water availability. Surakarta City initiated to use their 3 rivers across the city as one of the surface water resources to ensure water availability and preserve the environment. Changes in land use worsened by climate change will affect the quantity and quality of water resources. So to make river water as a clean water resource, an assessment of the river and its surrounding areas needs to be carried out as this research aiming, because it will affect the water entering the river. This research used land use and river water quality data both in 2018 on 3 major rivers in Surakarta, Pepe, Premulung, and Anya River. Land use information gathered from satellite imagery, 500 meters area from each river, while the river water quality gathered from secondary data from environmental services of Surakarta City. The assessment used spatial grouping analysis by geographic information system from 15 variables, 2 variables from land use aspect, and 13 variables from river water quality. This is the river water quality of 3 rivers in Surakarta on 2018. The first line, which colored yellow, is the baseline of source of drinking water based on government regulation regarding to water quality management and water pollution control in Indonesia. From this data, we can see that no river water in Surakarta that is included in first class that can be used as a source of drinking water. We also identify the land uses 500 meters around each river and found that the majority of the river is surrounded by residential land use that produce grey water which flowed into the river. This diagram here also shows the land use proportion in each river. Based on the water quality and land use characteristic, we try to make groups which has various typology. These groups is very beneficial to make an intervention for providing clean water from these 3 rivers. We start from group 1 with blue color on map has big portion of settlements, including textile industries on the upstream. Some of these industries has wastewater treatment plant actually, but has inactive at the moment. So some of them, they drain their waste into the rivers. The water quality in this group is very far exceeding the criteria, especially the content of the total chloride, sulfur, chlorine, and phosphate content. Some land uses in Group 2, the pink one, consist of urban infrastructure which managed by the government, so the waste is managed carefully. At the Group 3 with green color, there has quite a lot of green spaces around the river, but the water quality is also not better than others. Even in the midstream to downstream of Anyar segment, the total chloride content is up to 90 times from the water quality standard required for drinking water. On the Group 4 with orange color has a variety of land use types but has very little of green open space. The water quality of midstream to downstream PP segments also were far exceeding the first class quality standard, with total E. coli is 80 times from the standard. From those four groups typology, especially the bad quality of water at Group 1 and also the high of E. coli content at Group 3 with dense population and settlements, we can see that intervention is not only needs to be done on the river itself, but also land use activities related to the river. Based on the results, we can conclude that first, not only using drinking water processing technology is necessary, but also regulation for land use and community activities in the river basin. So the management in land use and community activities is needed. And the third, industrial wastewater treatment plant needs to be reactivated, and grey water processing from residential activities also needs to be encouraged. We suggest that future research can find more about the root causes of the river water quality, more detail on the infiltration capacity or the wastewater system before it flow into the river, and also the activity from the upstream in the other region which flow into the three river in Surakarta. This is some references that I used. That's all for me. Thank you for the time.
Thank you, Mrs. Erma. Any question for Mrs. Erma? Not yet. Not yet.
Okay.
Okay. Any question?
Yeah.
Okay, Bu Nunung.
Yeah.
Sis Nunung,
Thank
okay,
you.
please.
Thank you, Ibu Erma. Very interested your mapping. Ibu Erma,
Yeah.
when you take of parameter from water quality watershed, how the analysis usually regulation government give of the analysis until become of mapping land use. Thank you.
Yeah, okay. Thank you, Bu Nunung, for the question. Maybe my water quality is based on secondary data actually. So this is from the Badan Lingkungan Hidup. So from the Badan the water quality, and then use the data with the land use data. I collect the land use data, and then from two types, for land use and water quality, I input the data into the geographic information system, so we can result the grouping, so we can use four groups, and each group has typology. Each typology is different one with another based on the land use and the river water quality.
Type of GIS?
Yeah.
And
Yeah.
GIS. I'm using ArcGIS, and for the tools, I'm using the groupings, statistic grouping analysis, one of the tools on the ArcGIS. You can find it on ArcGIS.
Thank you, Ibu.
Yeah, you're welcome, Bu Nunung.
Okay, thank you, Mrs. Erma and Mrs. Nunung.
You're welcome.
We continue the next presentation. The next presentation is Mr. Rahayu. The title potential use of leaches for tough grass irrigation on soil covered landfill Suwong, Bali. Mr. Rahayu will present directly by his PPT. Okay, please, Mr. Rahayu, please unmute us.
Thank you very much. Actually, I don't prepare the video, so I want to present directly. Yeah, so I will share my screen. Just wait a minute. Okay, now wait a moment. Okay, thank you very much for moderator give me the time for present. Actually, I will present about the potential use of likat for turf grass irrigation on soil covered landfill Suwong, Bali. We know that Bali is
very
famous
famous
for
for
tourism, but
tourism, but
many
many
people and
people and the
trash
trash
very
is very
many
many
also. So
also.
they
So
collect
they
the
collect the
trash,
trash,
garbage in the
garbage in the
landfill.
landfill.
The
The
landfill's name
landfill's
is
name is
Suwong.
Suwong.
Suwong is
Suwong is
between
between
the
the
airport and
airport and
also
also
Bali, Denpasar. So this collect the Denpasar
Denpasar
garbage. So
garbage.
this
So
very
this very
important because
important
the
because the
environmental
environmental
problems.
problems.
Government
Government
want to make
want to make
this
this
landfill become
landfill become
a park
park
area.
area.
So
So they
they cover the landfill using 1.5 meter by using soil, yeah? And then after that they want to plant the many planting, ornamental planting, and especially turf grass. This I saw in the figure that this situation about the landfill of Suwong in Bali. Yeah. So we know that if they use water for irrigation, that's very difficult. So they use the very bad quality of water for irrigation. Because they won't use the leakage from the landfill to irrigate the turf grass in this new parks like that. So the challenge is selection of suitable plant species and optimum concentration of likat are important. Very important. Okay, I will let the slide show. Okay, I'm sorry about this. Okay, this situation about the Suwong in Bali landfill, and usually many hundreds of cow eat the trash. This is also problem. So many very bad smell, and this is problem for tourism in Bali and also environment. But make a park is not easy because for irrigation is very important. So we do the survey of the situation. How possible likat of this landfill used for irrigation the grass, and So the challenge is selection of suitable plant species and optimum concentration of lichens are important factor in the prevention of vegetation damage when use lichens as irrigation. Yeah. And we know that turfgrass is the most widely used plant for phytoremediation activity, and grass is also widely used for landfill area suitability and biology reclamation. And material method, we just survey, and then using check point by point with using random point. Yeah. Started with random sampling, and then after that we determine and also we bring a sample of water, measure the characteristic of water, and then we check how life, how bad situation of the grass. Result and discussion, we find that this is a situation of water, and almostly water is very bad quality for irrigation. Mm. And then we also find over there are six turfgrass cultivar. Native Bermuda, we call actually in the Latin name is Cynodon dactylans native, and also Scissor paspalum with Latin name is Paspalum vaginatum, and also Cynodon dactylon hybrid, Paspalum hybrid, Zoysia matrella, and also Axonopus compressus. This characteristic, and almostly 40% of this landfill is covered by native Bermuda and also native Scissor paspalum. The conditions is we find that the native Scissor paspalum grow very well. The other seems like native Bermuda is like the injury, Bermuda hybrid is stress, and the paspalum hybrid also some stress. Joysia matrella is like the injury, Axonopus compressus. We usually call this rumput gajah mini. That's very heavy injury. Also, we check in the condition. We can show at the picture that in the top turfgrass still grow well, but in the slope turfgrass grow is very difficult. We know that in the top usually is okay because the irrigation is very easy, and also there are no liquid, additional liquid come out, but in the slope liquid is come out, and then this very make this turfgrass very stressed. Result and discussion scissor paspalum, it is in this picture so that turfgrass die by using liquid, but the some area also turfgrass also can grow when irrigated by liquid, and we find in the turf in the ponding in the foot of hill of landfill, we found that paspalum, Scissor paspalum or Paspalum vaginatum native grow very well, uh, even soak in the liquid condition. After that, we conclude that in the Suwong landfill covering area with 1.5 meter thick soil, there are 6 main grass, namely local Scissor paspalum, local Bermuda, Zoysia matrella, hybrid Scissor paspalum, Bermuda hybrid, and Axonopus compressus. The use of well water mix with liquid for grass irrigation for years showed a variable response based on grass type and position on the landfill hill. The local Scissor paspalum grew well. Local Bermuda and Zoysia material show relative less growth inhibition than the Bermuda hybrid, and also Axonopus compressus the most stress. This means that using liquid for irrigation is okay if the grass is Scissor paspalum local. This is the reference. Thank you very much for attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Rahayu. Any question for Mr. Rahayu? Okay, Mrs. Jori Samsia, please, it's your time.
Thank you, moderator. I will ask about lichet. Can you please explain to me what is the lichet? It's not used for plant or at base or another one? Okay, thank you.
Directly.
Please unmute first.
Okay, thank you very much for the question from Ms. Chauri Somsia. I want to explain that what is the meaning likat? Likat is the water come out from the landfill and the color is black. Usually it's very high pollution, and usually it's not used for irrigation. Usually this become pollution problem, environmental problem. Make some pollution, usually the organic uh, usually is carbon dioxide dissolves very high, and also usually in these cases salinity also high, so that's not easy for irrigate to the plant, because only very tolerant to the salinity and bad quality of plant they can accept as irrigation. In this case, just scissor paspalum local is accepted, this likat become irrigation. Usually in case this project, the government using liquid water from ponding and pumping to the up and using for irrigation to the grass. So if the some many grasses is dead, but only paspalum and also joycia material still okay. But in this case, scissor paspalum is grew very well, but the other stress. So very difficult to use the liquid water to irrigation. Usually in the case if they pull into the sea, become problem for the fish. If they come to the rice field, they also make toxicity in the rice field, something like that. So this is the main likat. So likat is mean we call in Indonesia we call lindi. Lindi. It's a very difficult use, but the so very careful and very selective situations like that. Okay, like this. This I try to answer. Any other question, please?
Okay, Mr. Rahayu, because the time is past, we next presentation, we continue the next presentation is Mrs. Jawari Samsiah. The title is Selected Soil Nutrient Availability, Plant Nutrient Uptake, and Upland Rice Yield in response to rice straw and mycorrhiza application.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. First of all, we have to say thanks to Allah Subhanahu wa Ta'ala and thank to all committee of ICCC for the effort to make a good conference today. Okay. First of all, I will introduce myself. My name is Jawari Samsiah from Universitas 11 Maret, Surakarta. Now, we move to my presentation. I will share my PPT. Okay, the title of my presentation is Selected Soil Nutrient Availability, Plant Nutrient Uptake, and Upland Rice Yield in Response to Rice Straw and Mycorrhiza Application. The introduction. Nowadays, global warming or climate change is getting a lot of attention from many institutions. In agriculture, for example, global warming such as a long dry season can cause increase in land area that cannot be used for agriculture or for plant cultivation, because in this area, lack of water and low soil fertility. Therefore, it is necessary to overcome this problem. One of the alternative to overcome this problem is using organic matter. We know that using organic matter to the soil can improve soil physical properties, soil chemical properties, and soil biological properties. And overall, using organic matter like rice straw can improve soil properties and soil fertility. On the other hand, organic matter such as rice straw as a source of nutrient for plant growth and can give a good condition for plant growth. Mycorrhiza has many roles to the plant. It can help plants to absorb nutrients so that can increase plants yield. Many researchers also said that mycorrhiza can help to decompose organic matter. So if we use rice straw together with mycorrhiza, it will improve nutrient available and can give a change on increasing nutrient uptake and crop yield. Furthermore, it can mitigate climate change. The purpose of my research is to determine availability, nutrient uptake, and paddy field on the dry field by use rice straw combined with the mycorrhiza. The material and method. This field experiment used completely randomized block design with 2 factors and 4 applications. The first factor is rice straw, consists of no straw or control, fresh straw, and weathered straw. And the second factor, that is mycorrhiza application, consists of with and without mycorrhiza. Using rice straw in the field, before using rice straw, cut into small sizes and then it spread thoroughly in the plot 1 month before transplanting. And application of mycorrhiza we given along with the transplanting rice plant IR64. The parameter were observed is soil nitrogen total, soil available phosphor, and soil exchangeable potassium or soil available potassium, soil carbon organic at soil before treatment, and nitrogen, phosphor, and potassium in plant tissue and rice yield. The data from this experiment were analyzed using analysis of variance or test and continued with Duncan multiple ring test and correlation test. The result and discussion. The soil that used in this experiment has a relative low fertility because many soil characters such as carbon organic, nitrogen total, available phosphor, available potassium, classified very low to low, and soil CEC is medium. And the straw that used in this experiment has a different quality. Weathered straw has higher quality than fresh straw. It can be seen here, carbon and nitrogen ratio at weathered straw is lower than fresh straw. The content of nitrogen total in the soil, available P and available K in the soil by using straw and mycorrhiza can see in the table 3. Using rice straw, fresh and watered straw, and mycorrhiza inoculation can increase soil nitrogen total and soil available phosphorus significantly. We can see here that total nitrogen rank from 0.1 to 0.17 and available P from 8.08 to 9.70 and available K from 0.66 to 0.52. There is a significant increase in total nitrogen and available P, but no interaction between soil rice straw and mycorrhiza on available P. The higher total nitrogen and available P in the soil found in the using weathered straw and mycorrhiza. The nutrient uptake using mycorrhiza with fresh straw or weathered straw could increase nitrogen, phosphorus, and potassium uptake significantly. The value of nitrogen uptake ranges from 0.45 to 0.79 and P uptake range from 0.15 to 0.25 and potassium uptake range from 0 to 0.09 to 0.25. The highest uptake of nitrogen, phosphorus, and potassium found in the using of mycorrhiza and weathered straw. The application of mycorrhiza combined with the fresh straw or weathered straw significantly increase rice yield up to 20% than control. We can see here that using weathered straw and mycorrhiza give the highest rice yield, about 3,500 16 kilogram per hectare. The conclusion, the application of straw combined with the mycorrhiza inoculation can improve the availability of soil nitrogen, phosphorus, and potassium by 65, 81, and 110%, and the uptake of nitrogen, phosphorus, and potassium by 72, 105, and 172% than control, respectively. The highest grain yield about 3.9 ton per hectare we found in the use of weathered straw and mycorrhiza. An application of rice straw in any condition can optimize soil fertility and can be used as a way to adaptation to climate change. This all my presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you very much, Mrs. Jauhari Samsiah. Any question for Mrs. Jauhari Samsiah?
Can I ask?
Okay, Mrs. Sumiati, please.
Okay, thank you for the moderator. I want to ask about how many rice straw applied at the treatment in this region. Thank you.
Oh, okay, thank you. Mrs. Jauhari Samsiah, please respond the question.
Thank you for your question. I use 10 tons rice straw per hectare in this experiment.
Okay, enough. Mrs. Sumiati.
Okay, thank you. 10 ton. Okay, thank you.
Okay, the next question, Mrs. Sri Yusnaini, please unmute first.
Okay, thank you very much. I want to ask that the mycorrhiza that used to inoculant, what kind of mycorrhiza, and how much the application of inoculant mycorrhiza. And the second, I want to know the straw of rice and the wheat rate make the same result. Why? Because the first is the fresh and the second is the winter. So why that the result have the same effect to the absorption of nutrient? Thank you very much.
Okay,
Thank you.
Please.
Okay. Mycorrhiza that I use in this experiment is a fertilizer mycorrhiza, not just mycorrhiza, but fertilizer, because there is the fertilizer beside content of mycorrhiza. There is a carrier like zeolite, and I use 5 grams per plant. Example fertilizer mycorrhiza. And why the last question maybe why the rice straw and water straw give same result? I said that in the experiment using water straw give the higher result and on soil fertility. I mean that on availability of nutrients, and then nutrient uptake and rice yield. Is using water straw is give a higher result, not the same.
Thank you very much.
But if we compare to the control, the use of fresh straw give a higher result, higher yield than control.
Yes, thank you very much.
Okay, thank you.
Okay. Thank you, Mrs. Jauhari. Thank you, Ms. Sri Yusnaini. We continue to the next session. The next session will be facilitated by Mr. Rahayu. And we with Mr. Rahayu. So maybe the next presenter is Miss Sumiati. The title is the effect of screen material on the microclimate and growth of chili pepper plant. Mrs. Sumiati, you
Present our
ready?
paper. I would like
Yes.
to present our paper about the effect of screen materials on the microclimate and growth of the chili pepper plant. This paper has output our research, who the team is Mi Sumiati and Ibu Ida Ayu Bintang Madrini and Bapak Iwayan Tike from Department of Agricultural and Biosystem Engineering, Faculty of Agricultural Technology, Universitas Udayana, Bali. Introduction. Chili pepper plant can grow and produce optimally, must be planted in an environment that is in accordance with growing condition. The growth requirement include altitude, planting medium, and microclimate. Climate change that have been happening lately often causes failure in cultivation, so the microclimate modification is needed. The screen is used in chili pepper plant cultivation as a method for climate modification, which was initially not suitable to the plant. Agriculture is one of the sector most vulnerable to climate change. The use of screen is highly recommended because it can reduce the growth of the pests and disease, increase production, and plant can be planted throughout the year. The screen that is usually used in plant cultivation is a screen made from plastic. The use of screen made from shading net and combination of plastic and shading net has not been studied. The purpose of this study was to determine how the growth of chili pepper plant on several types of screen materials and to determine of type of screen material that is most suitable for the cultivation of chili pepper plants. This research was conducted in Subak Suala, Tabanan Regency, Bali, Indonesia. The materials and tools used were cultivation materials like chili pepper seed, planting media, irrigation water, fertilizer, and pesticide. Screen materials consist of UV plastic and screen net with a density of 50%. Tools for cultivation, bamboo for frame structure of the screen, and the other research tool. Dimension for the frame structure of the screen are 2 meters high and 1 meter wide, as shown in figure 1. This study consists of 4 treatments. There are no screen, UV plastic screen with 0.6 millimeters thickness, shading net with 50% shade factor, and a combination of UV plastic and shading net. Each treatment was made with 3 replication. The variables of search were plant height, number of leaves, the first flower appearing, dry weight, and productivity. Result and discussion. Climate screens and shade net have two main uses in controlled environment horticulture. Shade net can be used to shade house and are sometimes combined with plastic cover. The higher level of shade net, the lower light intensity received by plant. A decrease in light intensity is followed by a decrease in temperature and an increase in air humidity, which will affect plant growth. As can seen in figure 3, with screen treatment, there are no screen, UV plastic screen, shading net, and the combination of plastic screen and shading net. The results of observing plant growth indicator in this study are as follows. Plant height. plant height is the size of the plant most often observed as an indicator of growth. Based on figure 4, it can be seen that at 35 days of age, chili pepper plant under the shading net screen show the highest growth with a plant height of 30.65 centimeters. Plant under shading net screen show higher chili pepper plants compared to plant under other treatments. Number of leaves. The number of leaves is an indicator of plant growth. Based on figure 5, it can be seen that the number of chili leaves under the shading net show the highest number of leaves. The use of shading nets allow the microclimate condition around plants such as light, temperature to be manipulated to be optimal for plants. The first flower appearing. The first flower appearing was observed in its plant that began to appear flower bud. The result of this study indicate that the chili pepper plants on no screen, plastic screen, and the combination screen had slower growth compared to the shading net screen, as can be seen in figure 6. The difference is caused by several things, including the intensity of sunlight, where the amount of light received by plant under the shading net and the combination screen is lower than plants under the plastic screen and no screen. Dry weight. Dry weight with measurement data for its treatment can be seen in figure 7 that shown the chili pepper plant that were under the shading net treatment produced the highest dry weight compared to the other treatments. The greater of level of shade is inversely proportional to light intensity received by plant. The amount of light received in the photosynthesis process show the biomass, while the amount of biomass in plant tissue reflect the dry weight. Plant productivity. The average productivity of each plant in its treatment can be seen in figure 8. The productivity of chili pepper plant with shading net is the highest compared to the other treatments. High light intensity will increase leaf temperature as a result of disrupted enzyme activity. Among other things, this can cause photosynthesis to be inhibited and the resulting photosynthesis is low. Conclusion. Cultivation of chili pepper plant in shading net screen material showed better growth as higher plant height, the higher number of leaves and faster the first flower appearing, higher dry weights and higher productivity compared to no screen, plastic screen, and the combination shading net and plastic materials. The type of screen materials that is most suitable for the cultivation of chili pepper plant is shading net. These are some of the reference used. Thank you for the opportunity to present our paper. I hope the result of this research are useful. Thank
Okay, thank you very much for Ms. Sumiati for the very interesting presentation, and thank you very much. Also, I will tell to you all that in this time start this time until finishes, I'm the moderator of this session. Yeah. Thank you very much, and then I hope this many we have 5 minutes for discussion. So If you all participants have any question, please raise your hand. Please, thank you. Any questions? Please raise your hand. Okay, if no question, I'll little bit about question. But do you measure if in your experiment? Do you measure the how much reduction of solar intensity, seems like that, and how the etiolations happen in your experiment? Thank you.
Thank you for the question. For the solar radiation, we measure it, but we not shown here. Not shown here. And but for the sorry, for the microclimate condition under the shading net, cooler than the other treatments. Maybe because the combination treatment and plastic treatment, there are have a effect of greenhouse apa namanya, efek rumah kaca, effect greenhouse effect.
Greenhouse
yeah.
effect, you mean? Yeah.
Yeah, and then this condition so effect for growth and plant productivity. But for the etiology, we not measure it.
Usually use the seems like you use paranet for protecting. The important is measure the how much the reduced temperature and also how much the reduce of solar radiation is very important.
So reduce it.
So if you so the data in this presentation, I think will beneficiary for you for us for become more a bit better information for us for understanding perspective. It's just suggested next time maybe in the future you can show the data about the reduction of temperature and also the solar radiations like that.
Okay, thank you for the suggestion.
Okay, thank you. Any others to ask about this presentation? If no, so we can continue the next presentation. Okay, no others? Okay, we continue. Thank you very much for Mr. Sumiati for your presentation, and then we invite Mr. Ongko Cahyono for next presentation, please. Mr. Ongko Cahyono.
Warahmatullahi wabarakatuh. Good morning, everybody. My name is Ongko Cahyono. I'm from the Department of Soil Science, 11 Maret University at Surakarta. In this time, I would like to present our study concerning about improvement of phosphatic fertilization method in soybeans cultivation. There are some reasons as a background of our study. That is the demand of pea fertilizer for crops, especially for seasonal crops, is high. However, its efficiency is low, usually not more than 20%. This can cause increasing fertilizer factory to produce more and more fertilizer. And because of the intensive production in the factory, that can increase gas emission to the air. And in turn, it contribute to the warming climate, which can induce the climate change. Therefore, increasing the efficiency of pea fertilizer is urgent. And one of the way how to increase pea fertilizer in seasonal crops is by applying the fast-soluble phosphatic fertilizer, as we done before in rice plant. In the study, we try to use the FSP fertilizer in soybean, and we try to the treatment of several doses of FSP in randomized design that is consists of 6 treatment and 5 replication. The treatments can be seen in the table 1. And for this reason, for this study, we measure 2 variables, that is soil and plant. After we harvest the soybean at the vegetative growth phase, we analyze soil on pH and available phosphorus. And for the plant, we measure the plant height, dry shoot and root weight, P uptake, apparent phosphorus recovery, physiological efficiency, and agronomical efficiency. And the result we can see in table 1 that the soil pH and available P in the soil after harvesting the soybean, we can see that the soil pH doesn't change, and that means that the application of P fertilizer did not affect the soil pH. However, in the available of phosphorus in soil, there is a significant increase depend on the dosage of the P applied. And we can also see the growth of the plant after we treat it with the P fertilizer in the table 2, yeah, that we can see that the growth of the soybean from the plant height and dry weight of root and shoot both affected by the doses of the P fertilizer applied. Also, for P uptake by soybean, we can see in the table 2 that the higher the doses we apply to the plant, the higher the P uptake by plant. And efficiency of uptake, P uptake by the plant, we can see in the figure 1, the effect of FSP treatment improve the P uptake efficiency. We can see from the table, the graph in the figure 1, we can see that the use of higher doses of FSP will increase the P uptake efficiency by the soybean. This is P1 as a control treatment. That is the application of SP36, or we call SP36 fertilizer. And we can see P3 and P2 is higher than P1. This indicates that using FSP will increase P uptake efficiency. The P uptake efficiency of the FSP and the lower doses did not increase the efficiency. And the second, we also measured the physiological efficiency. From the figure 2, we can see that the physiological efficiency increases with the decreasing dose of P. We can see, yeah, in the graph that the less doses we applied will increase the physiological efficiency. High physiological efficiency indicates that the plant is able to convert optimally the nutrient absorbed from the fertilizer into the biomass of the plant. And the parameter we measure that the agronomic efficiency. The agronomic efficiency shows the number of plant biomass produced from every gram of P added as fertilizer. We can see that the agronomic efficiency of the treatment of FSP is higher than that of the control treatment or SP36 treatment on here in the figure 3, we can see in the P1 treatment. So for the other FSP, even though it is a lower dose compared to the P1, that's indicate the higher agronomic efficiency will be result. Okay, so that what we done, and finally we can conclude from this research that the application of FSP fertilizer increases growth and efficiency of P fertilizer of soybean. And one suggestion, further research is needed to evaluate the yield response of several soybean varieties to the use of fast soluble P fertilizer. That's all our presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Mr. Ongko for your presentation. The presentation about the usage of phosphate fertilizer. Any question? Please raise your hand, please. Is there any questions? Okay, I will ask a question first before the others of participant. I will asking what is the principal difference between FSP and SP36? Why causing the absorption efficiency is different? Like
okay, thank you, Mr. Ayu. FSP means that it is a more soluble after the fertilizer is applied, and maybe in 2 or 3 days the available of P is ready to absorb by the plant. But for the SP36, this takes a long time. So when we try to apply SP36, not only take time to supply for the plant, but also it is not efficient because most of the soluble P from the fertilizer is absorbed by the usually Fa or Mn or Al in the soil, especially in the red soil. So when we applied FSP, in this case, we try to apply in split application, not once time, but in several times. In this case, we try to 2 times after 15 days after plant and 30 days after plant. That's the principle of the difference between SP36 and FSP.
Okay. Any other? Okay, so this means that the SP36 is slower release than FSPs, right?
Yeah, betul. Yeah, right.
Betul.
Sorry, Mr. Ayu.
Very interesting. Okay, okay. Okay, any other question? Is no questions. Okay, so this
Yes,
means that.
yes.
Please, Mr.
Yeah.
Mrs.
Yeah.
Nunung, monggo, please.
Okay, thank you, Pak Rahayu. Pongko very interested. In agriculture and fertility, soil fertility, very much of determine of efficiency agronomic, efficiency uptake, efficiency use fertilizer, and very much. I want to know what's the formula you use determine of efficiency agronomic.
Okay.
Efficiency agronomic, efficiency fertilizer, efficiency uptake, and many determine of efficiency. Thank you.
Okay. Yes. I reference from the experiment by Mengel and Kirby in the year of 2001. Yeah, there is a formula. For example, efficiency of P uptake. There is a measure from the P of the uptake by plant that is not fertilized compared to the uptake of P by the plant that is fertilized, and then divided by how many P is added to the plant. That's from for the efficiency of P uptake. And efficiency of agronomic phosphor, there is a measure from the biomass that resulted from the growth of the plant that is fertilized and compared to the biomass of the plant that is not fertilized, and divided by P added. There is also for the physiological phosphor efficiency and efficiency of use P by the plant. That's also we use reference. Yeah.
Thank you, Pak Ongko.
Yeah.
Okay, enough. It is still 1/2 minute. So maybe next time, if you have Mr. Ongko have data, seems like how many days the FSV will offer game offer the release, and also how many days the SP36 will offer the release. I think will better for us to understand, and also very better information, something like that. Do you have like that this data?
No, not yet.
Not yet. Okay, this just suggestion. Thank you very much. Okay, this very interesting. We meet in next time in the department, Mr. Ongko, for next discussions. Thank you very much for. And then we continue to the next presentations. I try to invite Mrs. Atiqah Aulia Hanif. Hanuf or Hanif?
Hanuf, yeah.
Hanuf. Oh, I'm sorry. Okay. Oh, usually Hanif. So I got. Okay, please. This is your time, and also you need you have 10 minutes for your presentation. Please, the time is yours.
Good afternoon for all the participants of the 5th International Conference on Climate Change. My name is Atiqah Aulia Hanuf from Brawijaya University. Today I will present the
Excuse me, can you increase your sound, please?
Water conservation. The title is Compost Filter Technology in Increasing the Available Soil Moisture Capacity in Coffee Plantation. Okay. The first at all, many countries have felt climate change in the form of increase in temperature, change in rain intensity and rainfall pattern, and season periodic. For example, rainy season has too much rain, or dry season lasts longer than usual. The temperature and rainfall condition affect the physiological activity of the coffee plant and also can affect the available soil water. Lack of water available will has an impact on the morphology and physiography of plant, as well as the cause of decreased plant productivity. Therefore, soil management plays an important role to support the growth and the development of the coffee plant, include soil water management and soil fertility management. Soil organic matter can increase nutrient availability, reduce the rate erosion, maintain soil moisture, improve soil aeration and drainage, reduce bulk density, increase water holding capacity, and increase soil porosity. And then technology is needed in order to prepare the effective adaptation and mitigation strategies, improve soil condition, and improve effectiveness of fertilization. Compost biopore technology is designed to put as much as water possible into the soil. This principle aims to reduce the runoff rate and other nutrient losses. Research on compost biopore technology focus a lot on the role of biopore in reduce the runoff rate and infiltration, but other functions such as controlling plant water requirement, improving soil water characteristic and soil quality, and also plant productivity have not been widely studied. So further research is needed in order to obtain an optimal compost biopore technology design in coffee plantation. This research was conducted in 2019 and 2020 at Afdeling Besaran, Blok 3, PTPN 12, Bangunan, Malang Regency. The type of coffee that planted at PTPN 12 Bangunan was Robusta coffee. This research was conducted in factorial randomized block design with 4 replication. First factor is biopore depth and second factor is compost type. This is the the treatment, combination treatment 1 to 7, and this is the treatment map. The research plot size was 9 and 12 12 meters with the 15 coffee plant, and 3 main sampling plant in the middle of treatment plot. In one plot research, there are 10 biopores. The biopore application at coffee plantation, the construction of biopore is made using a biopore drill with a diameter of 20 centimeters and a pipe diameter of 15 centimeters. Coffee pulp, waste compost, and good manure compost are inserted into the biopore according to the dosage. The dosage for good manure compost is 4.4 kilogram per tree, and the dosage for coffee pulp is 10.4 kilogram per tree. The research parameter were bulk density, particle density, total porosity, and soil moisture capacity. Soil sampling consists of 3 depths. These are 0 to 20 centimeters, 24 40 centimeters, and 40 to 60 centimeters. The bulk density measure with cylinder method, particle density with picnometer method, and then the calculation of bulk density. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon for the participants of the 5th International Conference on Climate Change. My name is Atika Auliahanu from Brawijaya University. Today, I will present the result of my research related to land and water conservation. The title is Compost Bioport Technology in Increasing the Available Soil. Increase in temperature, change in rain intensity and rainfall pattern, and season periodic. For example, rainy season has too much rain, or dry season was longer than usual. The temperature and rainfall condition affect the physiological. And then soil moisture measured with gravimetry method. This is the result of this research. Compost bioport technology, the first is bulk density, showed that positive result to bulk density. Control treatment showed that bulk density reached maximum value 1.47 gram per centimeter cubic, and the lowest bulk density was showed in the short biopore and coffee pulp treatment or SGB treatment of 40 to 60 in as big as 0.9 gram per centimeter cubic. That's it mean lower bulk density implied increased porosity and other soil characteristics that's suitable for biological activity and plant growth. And then particle density, compost biopore technology can reduce the particle density value on average, but not significant. The result, the level of particle density reduction from the control treatment was lower than biopore treatment. The highest decrease was found in the short and coffee pulp compost treatment or SGB. That means organic matter plays a role in binding the soil. If the organic material content is high, the particle density are getting lower. For the porosity, the results showed that the SGM or Search biopore combination with good manure treatment had the highest percentage increase. This is presumably because the percentage of organic carbon in good manure compost is higher than coffee pulp compost. It means that there was an improvement of pore size in soil, which is very important to the air and water balance of soil since aeration critical depends upon pore size distribution. The last is soil moisture. The highest increase in soil moisture were found in the LGM treatment or long biopore combination with good manure compost. Good manure compost has a high water content of 92.3% and the highest organic carbon content, it is suggests that the organic matter and biological activity had a major influence on the physical properties of the soil. In all samples, bulk density tend to increase with decreasing soil moisture. The conclusion is of this research is compost biopore technology impact positively for soil characteristics such as bulk density, particle density, porosity, and soil moisture. Soil moisture has strongly related to soil physical properties. Compost application can improve soil quality. However, the effectiveness of biopores has not shown significant result. LGM treatment or long biopore combination with goat manure compost is the best biopore treatment in increasing soil moisture. Uh, the reason of presumably due to the relatively short observation time. Therefore, it is necessary to observe a long enough time in order to get clearer result and also more complete analysis of research parameter. Okay, that is my presentation on this seminar. Thank you for have thank you and wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Ms. Atiko Aulia, that presented about the biopore technologies like that. I will ask to all the participants, if any question, please raise your hand. If there is no, so I will start make stimulant questions like that. But if is there any? Oh yeah.
Ada.
Oh yeah, yeah. Oh ada. Oh yes, please ada. Ibu Nunung ya, please. Silahkan monggo please. Ya,
Thank you,
yes.
moderator, Pak Rahayu. Bu Atika, very interested biopore. Bu Atika, why not the best from copy fab compost, and how much ratio carbon nitrogen from copy fab compost? I think the conclusion, copy fab compost, if the mix of blending, plus of starter microorganism local, may I product local wisdom. Okay. So LGM was the best biopore compost. Number one. Number two, may I ask number two, Bu Atika, how much distance your make biopore from tegakan coffee plant, ya? And coffee usually must be seeding under timber or plant wood, ya, because penyinaran matahari only sun only 60%, ya, and how depend on with biopore relative humidity efficiency. Okay, thank you.
Oh, please answer it quickly because only 1 minute you have for Mrs. Atiko to answer this question. Okay, thank you, please.
Okay, thank you for the question. Question number one is organic carbon. Organic carbon for the good manure compost is 32.28%, and the coffee pulp compost is 19.02%. This is big. Yeah, this make that LGM is the best treatment for this research. And then distant biopores. Number 3 question. Distance for each plant is 3 meters, and then biopore in the middle of 2 plant. It's about 1.5 meters.
Okay, thank you, Bu Atika.
Yeah, thank you.
Thank you, Rad. And actually, I have a question, but the time is already over. So I keep in my pocket. Next time I will throw out, and then I will ask the question for you next time. I hope we can meet again in another seminar. Okay.
Yes,
After that, after that we invite the next presentations about the water management for increased rice production in the tidal swamp land of Kalimantan. We invite Ibu Anna Hairani. Yeah, please, Ibu Anna Hairani, this is your time for 10 minutes your presentation and also 5 minutes for discussion. Yeah.
Warahmatullahi wabarakatuh. This review paper written by Pak Nur and I, we are from Balai Penelitian Pertanian Lahan Sawah, Balitra, Indonesian Swampland Agricultural Research Institute. Balitra is a national research institute under the IARD, Ministry of Agriculture, assigned specifically to study swampland for agricultural development around the country. On behalf of team, I would like to present about water management for increased rice production in the tidal swampland of Kalimantan, Indonesia, constraint, limitedness, and opportunities. Now we are going to introduction. Next. Tidal swampland is the land where its water regime is affected by water tide from the sea or river. Based on the influence of the tide, tidal swampland can be divided into 4 types. The overflow type illustration and explanation presented on the slide screen. Next slide, please. Based the authority area and infrastructure, water management differentiated between macro and micro water management system. Macro water management is under the authority of the Ministry of Public Works and Housing, which is mostly related to civil engineering. This water management includes management from primary, secondary to tertiary canals. Meanwhile, micro water management is mostly related to farming activities, such as rice field, which under the authority of the Ministry of Agriculture. Macro and micro water management should be implemented in an integrated management system. Next, we go to material and method, please. Okay, this paper will present several results of research and development of water management system in swampland, as well as development strategies for increasing rice production in Kalimantan, Indonesia. Next to the result and discussion. One of the key factors for successful agricultural development in tidal swampland is practicing the appropriate techniques of water management. In this section, we will discuss about swampland water management, their with constraint, limitedness, and opportunity, and the implementation of water management include infrastructure support and farmer participation. Next slide, please. As marginal land, swampland potential productivity is limited by variation of biophysical characteristics, include high soil acidity, low nutrient content, and the presence of toxic elements. Reclamation of swampland by land clearing and making canal will remove water from swamp and accelerate the soil ripening in order that it is suitable for cultivation and operational requirement of agricultural machinery. The reality in the field show that reclamation using heavy equipment causes the peat layer to be lifted, causing soil and water acidification to over drainage. Next slide, please. Oxidation of pyrite result in acidification of soil and water. On pit soil, there is irreversible dryness, which causes the soil cannot absorb water and subsidence of pit layer. It is difficult to keep swampland always wet or inundated. So, this case suggests the need of a careful applying proper management technique. Mismanaging of the land may produce degraded land and destroy natural environment. Besides limitedness from its management aspect, the reclamation takes a long time from the initial condition to the end of with the increase in the standard of farming living. Next slide, please. Agricultural development in swampland play important role to support national food security, especially in relating with the increase of population. The advantage of developing swampland as a source of food production that is abundant water availability, plant topography, doesn't require large-scale displacement. Certain area already have water system network and adapted to climate change, especially local rice varieties. Indonesia also has an opportunity to become a world food importer because supported by strategic conditions, such as tropical climate, which area of swampland for agriculture, and has a strong agrarian culture and local cultural wisdom in agriculture. By applying technology, crop productivity in swampland could improve as like we look at the two pictures in the slide. Next, we are going to slide implementation of water management. In this slide, water management that we discuss in here is micro water management, mean water management system at rice field. A two-way water flow system, also called conventional system. Most of farmers use two-way water flow system. Water supply and drain at the same canal so that water flows back and forth on the canal. This condition accumulate of toxic in the canal. The quality of water and soil changes to be more acidic and high level of toxic, which resulted in low rice yield. This slide shows the sketch of one-way water flow system. The system is designed so that water irrigating and draining the planting area through separate canal, so that there is an intensive flushing and leaching in this system. Next, please. In one-way water flow system, intensive flushing and leaching resulting in an increase in water and soil pH, followed by an increase in rice yield shown by these two figures. These two figures indicate that water management with one-way water flow system is better because it can improve soil and water quality, thereby increasing rice yield. Next, please. The implementation of one-way water flow system requires infrastructure support that connected canal and water get in the tertiary inlet and outlet, as we see in the upper picture. In the dry season, the tertiary canal can use as a long storage, so that dam overflow at bottom picture needed for filling the canal. Elbow system can build to facilitate water conservation during the rainy season for reserve in the dry season. Next slide. Because it is equipped with an irrigation system in the form of secondary, tertiary, and quaternary canal, water management involves many farmers or farmers group. The presence and strengthening of P3A group is very important in improving water management performance in swampland. Next, go to conclusion, please. From overview above, we can conclude that water management in swampland has an important role in improving land quality, leaching of iron and toxic compound, and increasing rice production. Water management in swampland faces several constraints and limitedness. However, it has an opportunity as a source of future food borne. The one-way has an advantage over the two-way water flow system. Implementing a management system requires infrastructure support, farmer participation, good institution, and digital-based water gate operation, or we call IoT, in the practice of water management. Next slide is the reference. Next is the slide is the reference used in this presentation. Next, please. Experiences indicate that development of agriculture in swampland by the application of technology appropriated to its characters could improve productivity and conserve its natural resources, as we seen in the last picture, rice performance during the World Food Day in South Kalimantan, October 2018. That's all my presentation. Thank you for your kind attention. Before ending this presentation, I would like to thank Pak Nur for preparing and accompanying this presentation. And for Balitra IT team, especially the Yuda, the Julian, and Bavika, great thanks for your helping in handling this too. Wassalamualaikum warahmatullahi wabarakatuh. Back again to Pak Arianto. Thank you, Pak.
Okay, thank you very much for your presentation. This very interesting presentation. Even the commonly the participant from Java, there is very low area of swampland, but in the case of Kalimantan, it's very large swampland. So this very interesting for us also. If there are there any question for this presentation, please raise your hand. Okay, all participants. Okay, if no, I will start some little bit questions, Miss Anna Hairiani. Oh, that in the subsidence, it's very interesting for us because usually we understand that for water management in the swampland, in the case of pit soil, we know the KHG, Kesatuan Hidrologis Gambut. So, is the first question is your presentation, but also accommodate about the KHG for piece of water management. The second question is how many centimeter for rice? For rice, that's acceptable for they still grow, but also prevent the subsidence, seems like that. Okay, thank you.
Apa tadi yang pertama? May I
yeah.
please repeat again for the first question, please? I can
yes,
hear your voice clearly. So sorry, because it's so late in Banjarbaru now.
My English is very bad. I'm so sorry also. Okay.
No, because you're so fastly.
Thank you. The first question is the KHG, Kesatuan Hidrologis Gambut. Usually it's very important piece of water management in the swampland. What do you think about the KHG, Kesatuan Hidrologis Gambut, about this situation? And the second is about the how many centimeter, the depth of soil, that the rice still grow well, and also subsidence can be prevented.
Oh, 1 meter. Okay. I will try to answer your question. Okay. I think it's important we have a kind of association like KHG. Yeah. It's important for preserve our swamp, especially our peatland. Okay. And for the second, the sustainable rice will be better growth in the 1 meter of the peatland depth.
1 meter. Maximum. Okay. So maximum, in 1 meter is no period exposed and then become oxidative like that. In 1 meter.
No. Because it's only pit only. Okay, but yeah, you must remember that every point of the soil there are very variation in swampland. Only in 1 meter is different with the other meter. So we must characterize first before we determine how the depth of the pyrite. Okay.
Oh, I see. Okay.
So the important I said that we must characterize the soil profile, something like that. Okay. After that, we must also analyze the soil's properties, something like that, before we manage the swamp.
So I mean that the pirate has become the main constraint to manage the water management, right? In your research,
Hi.
right?
Oh, sorry. Yes.
Oh, yes.
Yes, yes,
Japan.
yes. So because of that, before
Okay.
we manage the water management in the swampland, we must be careful to maintain the water level
Okay.
below beneath the pirate depth.
Okay. Thank you very much. I asking once more about for
Okay.
the participant. Is there any question? Other questions? Okay. If no question, please, Mrs. Anna Harini, maybe you have the final statement for this presentation and very core of
Oh
your
yeah.
information. 1 minute or half
Okay.
minute is okay. Yeah.
One statement for me. Okay.
Yeah. Okay.
I want
Focusing
to say
statement.
that experience indicated that development of agriculture in swampland by the application technology that appropriated to the characteristic of swampland could improve productivity and conserve its natural resources, as we seen in our research of result. So please conserve our swampland and become the future of food barn. Okay, that's something like that.
Oh,
Okay, thank you very
thank
much for
you.
you.
Thank you for very interested. And the more interested for us is if you next time have a seminar, invite us so we can visit your area in the swampland next time.
Okay, I will ask Mr. Professor Nur to accompany me, okay? Because he is the expert in swampland area.
Okay, thank you very
Thank you
much.
very much, Mr. Rahayu.
Yeah, Rahayu. Yeah, Rahayu. And then thank you very much. And then we invite to the next next presentations. I invite pipe presentation with the title biofertilizer increase master growth and nutrient status of dryland latosol. So I invite Mr. Sudadi for presentation. Please, your time is 10 minutes. Even though using video, but 10 minutes is important. Yeah, please, your time, the time is yours.
Thank you, Mr. Raji. Assalamualaikum warahmatullahi wabarakatuh. Me who presented our presentation with the title of Biofilm Biofertilizer Increase Mustard Growth and Nutrient Status of Dryland Litosol. We are Sudati, Aditrianto, and Suryono. As we know that all of sector in our life is influenced by the global climate change, included the the fertility of littoral soil. This research aimed to find out an appropriate dose of organic fertilizer composted with biofilm biofertilizer that optimally increase mustard growth as well as nitrogen, phosphorus, and potassium status at littoral. We try to create an innovative and adaptive strategy to manage littoral fertility and plant productivity only. We use biofilm biofertilizer and liquid phase and to composted organic material to make organic fertilizer that we use to manage soil fertility of little soil and to increase master growth on it. The inoculum of biofilm fertilizer consists of potassium sulfilizing, calcium sulfilizing, sulfur oxidizing, as well as non-symbiotic nitrogen fixing. And we also add piperia and trichoderma from the laboratory of plant pathology, Faculty of Agriculture, Plasma University. Next. We make the organic fertilizer. We decompose from the composition of phosphate rock, feldspar, sulfur, lime, and coal manure, and we decompose for 2 weeks before we use. We apply it and the land, and with the treatment doses of 0, 3, 6, 9, 12, 18, and 20 ton per hectare with 3 replication. We grow mustard and we observe the variable of plant head, subphosphate, and drawage, as well as soil organic matter content, soil pH, cation exchange capacity, total nitrogen, and available phosphorus, and exchangeable potassium. The data we analyze with a test at 95% level of confidence, followed by a Duncan multiple rank test when any significant influence. This is the soil properties of the little soil we use, and we can say that for general, the soil can classes as low soil fertility, as indicated by the very low organic matter content, total nitrogen, and available phosphorus. From the research, we can show that the use of organic fertilizer we decompose with biofilm fertilizer can increase soil organic matter content, total nitrogen, available phosphorus, exchangeable potassium, and calcium, cation exchange capacity. And they increase in line with the increase of the dose of organic fertilizer we use. And the effect of the organic fertilizer applied on plant growth can see in the short table that you can see that the growth has increased concomitantly with the increased dose of organic fertilizer we use. But until 21 ton per hectare application of organic fertilizer, and the optimum dose of organic fertilizer not yet achieved, maybe caused by the very low organic matter content of an initial soil. we can say that while the use of organic fertilizer decomposed with biofilm fertilizer can increase nutrient status and growth of mustard and litosol, because this organic fertilizer content of beside organic matter, also they contain nitrogen, phosphorus, calcium, etc. And also it contain especially from the biofilm fertilizer inoculum that contain many soil microbial that can increase the availability of soil nutrients such as phosphorus solubilizing, potassium solubilizing, sulfur oxidizing, etc. This in line with the result of the result of Sudati et al., Hadrian et al., as well as Brika. And also Galilei et al. State that the use of Xylus subtilis as biofilm fertilizer show a high benefit on lactose suspension than the plankton form. From the research, we can conclude that the application of organic fertilizer composted with biofilm fertilizer on litosol can increase soil organic matter content and nutrient status as well as mustard seed. But optimum dose of organic fertilizer use has not been achieved until 21 ton per hectare. This may be caused by the law of native soil organic matter content. Thank you.
Thank you for your presentation. Very presentation, and maybe some of participants interest to know about the biofertilizer, biofilm fertilizer. Please, we have 5 minutes for discussion. If any question from participant, please raise your hand. Okay, is there any question? Okay, we first seems like we in the case of myself, I very interested to and very want to understand what the main principle between biofilm, organic phylum biofertilizer and not not biofilm. What's the main different principles, and then why the biofilm fertilizer itu and then become very interest very important in your research, something like that, because usually it's very new sound in my ear that the organic film seems like that, because I'm and myself, yeah, I'm not from organics and microbiology, seems like that, so we don't know. So could you please inform us about the
Okay,
principle,
okay,
what is
Mr.
the
Rayu.
biofilms like that?
First,
Yeah.
I'm very sorry that my internet is my internet connection is open.
Okay, me. Okay, thank you. This still, Mr. Zaid, you still hear me? Okay. Okay, I think the problem is not my ear, but the problem is the internet. So, because the situations, maybe I will asking next time when I meet him.
Yes, I'm
Oh,
sorry. My internet is
already. Okay.
open and interrupted. Do you hear my speak? Hello?
Yes. Understand and sound. Your sound already coming out. Thank you.
Yeah. I will explain the difference between biofilm biofertilizer and ordinary biofertilizer. Biofilm biofertilizer is biofertilizer which the microbe can mix or pitch thin film of microbial. This is the principal differences between biofilm biofertilizer and ordinary or generally biofertilizer. Generally biofertilizer, the microbe cannot make or bed thin layer, thin biofilm microbial. This is the new technology for the application of microbe in increasing their capability to increase nutrient availability. By the bed of biofilm, they can do more than generally biofertilizer, and also they can defend from extreme or environmental experimental stress, I think. I think it
Okay.
is enough for your question,
Yeah.
Mr.
Yes,
Haim.
already enough. Any other from another participant? Sir and madams, please raise your hand if any questions. Madam Akta Harfia? No? No, okay, thank you. Madam Octavia, no question? No, okay, no question. Okay, the others because no question, so we can continue. Thank you, and also the time is already over because of I talking many, so it's okay. So we can continue in the next participants, next presentations. We invite the title about. Oh, okay.
Internet sanara mutu tenan.
I sound in the ears entet internet ramudu tenan. Okay, this very more evening and more evening because sometimes. Okay, I will continue the Ibu the title topics but comparison of fly ash and bottom ash as amelioran for post mining land to nitrogen, potassium, and so on. So we invite Ibu Nunung Sondari for this presentation. Okay, your time is 10 minutes. Please.
I share screen share myself.
Yeah, of course, please. Yes.
Okay, thank you.
It's like me. I already do like you before. Yes, so I please yourself to prepare your presentations. Okay, the time is yours. 10 minutes, please.
Yeah. Oke, thank you moderator para Hayu. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Konnichiwa. The first, we should be grateful in the name of Allah Subhanahu wa Ta'ala, beneficent and merciful. Blessing and salutation be upon the most honorable Prophet Muhammad Rasulullah SAW. Acknowledgement beside to thanks of Ministry of Energy and Mineral Resources, Bersibang Teknologi Mineral and Batubara, and Electricity Power Plant, or PLTU, Peto Indominco, East Kalimantan. Besides, I should never forget to thanks of protocol who has given me the opportunity in this good occasion desire to speak the title comparison of fly ash and bottom ash amelioran for post mining land to nitrogen, potassium, and heavy metal uptake of Albazia. We know coal mining and coal burning energy generation are the main engine being operated globally. Land degradation that occurs the mining activities create imbalance. Nature with is one of the sort of climate change. The other admitted opinion, the contribution of mining sector, especially coal to forest destruction in Indonesia, reached 10% and now drop 2 million hectares every year. So to overcome this problem, it's necessary to reclaim the former mining area. PT Indominco Mandiri, PLTU, the activity every day, use of coal, 240 tons, equivalent 7.440 tons per month. So equivalent 87,660 tons per year. And if we contain us in coal of 80%, the resulting coal ash is 19.2 tons per day, and equivalent 7 million tons per year. So capacity of electrical has 2 times 7 megawatt. The Ministry of Environment and Forestry has determined that coal as waste battery based on government regulation number 101 2014 year, hazardous and toxic material. So can follow it and endanger this environment. So landscape morphology, morphology Rona, the first of different from the last of mining. So must recover to initial state due overburden excavation and coal layer mining. We know, and I have a roadmap of research coal ash for agriculture and properties chemical. Coal ash contain macro and micro element and small amounts of element carbon and nitrogen, and the other types of beneficial elements such as silicate, sodium oxide, sulfate, and many other beneficial element. But physical properties of coal ash has a seed size particle, has moderate to high water holding capacity characteristic. The method of research, the first we analysis of toxicity characterizing leaching procedure, and Leta day 50. Leta day 50 to moss or white moss mencit in laboratory determine, and toxicity characterization procedure of heavy metal analysis. The research method, we experimental design factorial. It is of composition comparison A, 1000 play as bottom as, composition B, 75% play as bottom as plus 25% compost. Composition C, 50-50, 50% play as bottom as, 50% compost. Composition D, 55% place as bottom as and 75% compost. And composition A as a control of 10%, 100% compost. Or variation of the coas, water of peel capacity that is in condition. The analysis parameter of TCLP, bottom as, play as, and mixture. Why mixture? Because the Indominco PLTU in landfill not separated or between bottom and play as. So we made of analysis bottom or play or mix. And to be seen of the table, conclusion about micro element and heavy metal below the threshold and the threshold regulation Ministry of Environment. Okay. After mix of fly ash bottom ash and compost, condition of peel capacity, 10th day, we analysis in laboratories. For toxicology, value of LD50 greater than 5,000 part per million or milligram per kilogram, referring to the classification of the oral toxicity test from Whitehouse that as sample is classified or practical non-toxic. And so leach analysis determine of TCLP, heavy metal, low threshold of regulation Ministry of Environment and Forest. For variable plant height, that from 2 weeks after seeding until 10 weeks after seeding in the nursery, based on observation, there was no significant difference plant height between B, C, and D comparison, but with E significant difference. Why research in second house? Because we research of which season. Number of petiole, rod diameter, the diameter of seedling and albacea in albacea. Why this important rod diameter? Because albacea we know classification of a fast-growing plant, so needs of macro and micronutrient from composting play as bottom ash in the curva in the that composite is gray.
Okay, excuse me, Ibu Nunung.
Yeah,
That your
yeah.
time remain 3 minutes for presentations.
Yeah.
So
Okay.
please quickly presentation and you
Okay.
can faster.
The end. Okay.
Yeah,
And
okay.
root length and number of effective rod noodle, composition C 50-50 as bottom as on composting, very interested because have of microbial functional the greater between the other composition the other. So and conclusion, yeah. Coal ash is good for use as a soil amendment with comparison of 50% coal ash and 50% compost and give the best result of grow and increase nitrogen potassium uptake, can reduce heavy metal uptake residual effect on the chemical fertility characteristic of a good planting medium. We know that content of composition to be seen of table, nitrogen uptake from comparison A and D. I think of comparison C, 3.54% in the tissue lip tissue albacea. Potassium, the thing of interested because the adequate. Plumbum, yeah, plumbum 45 part per million, still below the regulation. And arsen not detection because very low regulation, 0.002 milligram per kilogram. Okay, thank you for give attention. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for your presentations. I think it's very important for also very interesting because many industries use coal for burning the coal and they resulting the waste as fly ash and also bottom ash, especially in the electric companies. So they produce many bottom ash and also fly ash and also this Ibu Nunung already make a research use the bottom ash and fly ash as become soil amendment or soil ameliorance. So is that any question from participant? Please don't hesitate to raise your hand, please. Okay. Yes, this is Ibu Octavia. Yeah, please, Bu, please. See, sit beside of me.
Okay, thank you. Thank you, Mr. Rahayu. I want to ask, there are for treatment for the ameliorant for post mining land to nitrogen. So please explain to me what the treatment that the best for the base.
Okay. Ibu Octavia, thank you. Comparison by us bottom us and compost, but compost to meet from fly ash bottom ash and later plantation. So massive, okay. If to make of 1 tons fly ash bottom ash 57%. Compost liter only 25% did compost. So compost made from like I bottom as a mix of organic matter.
Yes. Thank you very much for Ibu Nunung for your presentations and congratulations because I also tell you that in 10 around 11 years ago I also using the bottom ash for amelioran in the soil to grow some grass in the saline condition. So it is also so I little bit understand about the bottom ash. It's very interesting also. However, this your time is already offer. So thank you very much for your presentation. Thus, I will invite the
Pak
final.
Mr. Rahayu,
Yeah.
research stage 1, and we after FGD with Ministry of Environment and Forestry give the lampu hijau, ya,
Green light, yeah.
light for improvement that bottom ash play as no battery, yeah, again.
Okay.
Insya
Yeah, I
Allah.
understand. We also same
Thank you.
thing. Research, yes, thank you. Welcome. And then we invite the final, the end of the session for presentations. We invite the uh, the presentation about the application of soil amendment as a strategy for water holding in sandy soil. We invite Mrs. Octavia Herawati for presentations. The time is 10 minutes. And then please, Mrs. Octavia, your time, the time is yours, please.
The title is
This will using video. So I think for operators come please. Yeah.
The team is Octavia Herawati, it's me, Imam Arifin, Lucio, Jawari Samsiah, and Sani Kamal. We are from Soil Science Department, Universitas 11 Maret, Surakarta. Introduction. Climate change is referred to as a global warming phenomenon where there is a rise in greenhouse gases in the atmosphere. Effect of global warming on crop are increasing temperatures, increasing moisture stress, increasing drought, and crop damage from extreme heat. Global warming also will affect the various pattern of precipitation, evaporation, water runoff, and soil moisture. High evapotranspiration and unpredictable precipitation causes drought. Indonesia have a large of sandy soil area, but it has limiting factor for supporting plant growth, such as low water holding capacity, high infiltration, high evapotranspiration, very high soil surface temperature, very low organic matter, and soil moisture. To improve this condition, sandy soil needs soil amendment to increase the water holding capacity and decrease soil use through evaporation. The aim of this research was to determine the effect of application of soil amendments to increase water holding capacity in sandy soil. Material and methods. This research was a pod experiment that carried out in Sukasari, Jumantono, Karanganyar. Using a randomized complete design with one single factor, the type of soil amendments consisting of 7 treatments. P0 as control, P1 as cow dung 60 ton per hectare, P2 rice husk biochar 10 ton per hectare, P3 clay soils 10 ton per hectare, P4 cow dung 60 ton per hectare, and rice husk biochar 10 ton per hectare. P5 cow dung 60 ton per hectare and clay soils 10 ton per hectare. And the last P6 as rice husk biochar 10 ton and clay soil 10 ton per hectare. Okay, the soil. I'm sorry. The soil was safe to be homogeneous by separating plant roots, and then the soil was weighed at 10 kilograms and put into a polybag. Mix the soil with the soil amendments according to the treatment and incubated for about 4 weeks. During the incubation period, watering was done every 2 days, and at the end of period incubation, 1 month, seedling of chili was planted. Analysis, soil amendment were analyzed such as soil moisture, pH, soil pH, organic carbon, CN ratio, and soil texture for clay soil amendments. And then soil sample at harvesting. The analysis of soil sample at harvesting are soil aggregate stability with wet sieving method, soil permeability with constant heat permeameter methods, soil moisture, and soil porosity. Analysis data use SPSS 23.0 and one-way ANOVA test at 5% to compare between treatments, TMRT test to determine the significant difference between means at a significance level of P under 0.05 and then percent correlation test to determine the relationship between all variables. Result and discussion. Table 1 is initial analysis of sandy soil. We can show that the soil characteristic of sandy soil is not good. We can see that organic carbon very low. The value is 0.80%, and the total nitrogen very low. The available phosphorus very low, available potassium low, and CEC very low. And then the texture is sand with the percentage of sand is 92 to 23. Percentage of silt is 60.81, and then percentage of clay is 0.99. Next. Table 2, the characteristic of soil amendments. We use 3 of amendments: cow dung, rice, hooks, future, and clay soil. Cow dung have organic carbon 16.62, and then CN ratio 26.39, and rice hooks, future is the organic carbon is 18.07, and then CN ratio 33.3, and clay soil, and the organic carbon is 2.13, and then CN ratio is 10.7. The all soil amendments have CN ratio the upper 25. So it's called soil amendments, not soil fertilizer. Next, figure 1, the effect of soil amendments on soil physics a week after harvesting. Then tab figure 1 in the left up the top left, we can see that the combination of rice hooks, future, and clay soil or P6 was able to increase the best water storage capacity compared to the other treatment. The addition of rice hooks, future, and clay soil was able to reduce the cumulative infiltration capacity and increase the water retention capacity of soil particles. Figure 2 in the top right, we can show that cow dung 60 ton per hectare and clay soil 10 ton per hectare able to increase soil porosity. And then the figure 3, we can show that the combination of rice hooks, future with clay soil or P6 decrease the permeability rate up to 2.7 74 times than the control, and we know that giving clay soil to sandy soil will increase in aggregation reaction, which can reduce the rate of soil permeability. Figure 4 showed that the combination of cow dung and rice husk future was able to increase soil aggregate stability up to 1.87 times compared than control. Next, correlation between soil aggregate stability index, soil porosity, soil permeability, and soil moisture a week after harvesting. In the figure, the top left, we can show that soil moisture has a strong correlation with aggregate stability, with increasing soil aggregate will increase soil moisture. Soil aggregate is caused by addition soil aggregation is caused by the addition of clay soil, which function as a binder between particles, making it easier to form and soil aggregation. Next, strong correlation between soil moisture and soil porosity. Can show it the figure 2 in the top right. Rice husk biochar and clay soil are able to reduce infiltration and thus retain water from leaching. Rice husk biochar is able to reduce infiltration rate and soil permeability. The small size of the rice husk biochar particle fills the pores between the sand grains and partially closes the soil drainage, thereby affecting groundwater retention by reducing interparticle macropores and increasing micropores. The last figure, we can see that soil porosity has an effect on the decrease in the value of soil permeability. Like soil porosity is able to hold water more so that it can reduce the permeability rate. Conclusion and suggestion. The interaction of rice husk biochar 10 ton per hectare and clay soil 10 ton per hectare P6 increase water holding capacity and decrease soil permeability up to 2.74 times than control. And then cow dung 60 ton per hectare and clay soil 10 ton per hectare is the best for increasing soil porosity. Cow dung 60 ton per hectare and rice husk biochar 10 ton per hectare is the best for soil aggregate stability. Rise up to 1.87 times compared to control. And then there is strong positive correlation between soil moisture and aggregate stability and soil porosity. And there is negative correlation between soil porosity and soil permeability. Suggestion need long-term research to determine the effect of soil amendment to improve soil characteristic in sandy soil. Okay, thank you and see you next.
Okay, already finished. Finished presentation. And thank you very much. Very interesting for improving the water holding capacity in the sandy soil. So if you have any question, please raise your hand. Oh yes, Ibu Yusnaini. Ibu Yusnaini. Okay, please you directly can answer now. You can question now.
Yeah, thank you very much for Bu Atika. This your research is the same as my research maybe, but I'm in soil chemistry and soil biology, and you and soil physics.
Yeah.
That interest for me that you make the treatment explanation is for the cow dung is to higher 60 ton per hectare and the rice hold only 10 per ton per hectare. Could you make the reason for it only that's because we make the same research. Thank you very much.
Okay, thank you, Ibu Sri Yusnaini. I want to explain about your question. Okay, this is the second year, of my research of our research. The first research is about the dose of soil amendment, and we find that the cow dung at 60 ton per hectare is the best for sandy soil. As we know that sandy soil is have low fertility, such as water holding capacity, soil soil chemical, and then uh, so many. So in the second year, we try to combine the soil amendments like cow dung and then clay soil and rice husk biochar to increase the water holding capacity, like that.
Yes, thank you.
Okay.
Yeah.
Okay, thank you very much. We still remain 1 minute. So usually, this very in the case several research, they bring sand to the clay soil, and they bring clay soil in the sand land. That's very interest also, you know. So improvement not only using organic material, because organic material they can decompose and offer, but in the case if you bring clay many from clay soil bring to the sandy land, so this will remain very long time, and that's good research. Next time I think I will join your research next time, yeah.
Yes, thank you, Mr. Rahayu. I think it's need long-term research because clay soil and organic matter is maybe need a long time to uh, to research it. So just not 1, 2, or 3 months, I think, like that.
Okay, yeah. Okay, and then very interesting. I'm sorry to all participants. Actually, I already said that this is final, but I'm very sorry because one participant already uh, come back in the session before is another room. So we asking to the participant around 10 minutes more for one person for additional presentations. I'm sorry about even though I say that this already final, but actually one of our colleagues come back to this room, so we give her or him a chance to presentation around 10 minutes. So I invite uh, presentation number 4834 with title improving rice productions in saline soil. So we invite Ibu Yuli Lestari for presentation for present his research. Excuse me, Ibu Yuli Lestari, do you ready?
Yes,
Are you
I am
ready?
here. Yes, I am here.
Oh, okay.
I am ready in here. Yes.
Okay. Oh, I don't.
Okay.
Okay.
Yes.
So I give you 10 minutes for presentation. So please take time. Yeah.
Okay. Thank you.
Yes, Ibu Yuli Lestari, the time is
Okay, I'm
yours.
sorry. I'm sorry. PPT from committee or from me?
From yourself, because you already just come back. So
Okay.
from yourself, you prepare your PPT. So you can sharing screen
Okay.
in the Zoom. Yeah.
Okay. Uh, I I difficult this. Um,
May I just make some guidance how to how to share
yes.
the screen. First time you open the PPT in the
Yes. Yes. Yes.
open the PPT, and after
Okay.
you open the Zoom, Open Zoom, and then in the bottom you can make share screen. Share screen. You push the share screen. After push the share screen, you choose the PPT you already prepare. So of that, we can show
Yes,
your.
I will try.
Yeah. Okay. We wait.
Okay.
I give you 3 minutes.
uh, okay, I will try. Okay, where is uh, where is okay. Uh,
Okay. First time you open the Explorer, Window
okay,
Explorer,
okay,
and then you open
okay.
your PPT. Okay. Oh yes, good. This already you
Uh,
already successful. You can start. I give you
mm,
the time 10 minutes. Okay.
um, 20 menit. Okay.
Already ready, Bu. Ibu
Okay,
Yuli
yeah.
Lestari already. We the committee already prepare your presentation. You can do directly now.
Okay. Is okay. Uh,
Could you see the presentation we prepare?
okay.
Okay, you
I
can directly
can
now.
start. I can start now.
Yeah, you can start now.
Okay. 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 Thank you, Mr. Bapak Moderator. Uh, okay, I will introduce myself. I am Yuli Lestari from Indonesian Swampland Agriculture Research Institute. Assalamualaikum warahmatullahi wabarakatuh. Today I will present our paper with title Improving the Rice Production in Saline Soil. This paper is the result of a review from several studies on soil saline management for rice cultivation. And then, as we already know that climate change is a natural occurrence that cannot be avoided and has a wide impact on various aspects of life. And why does the climate change? The climate change because use of fossil fuels in various sector, deforestation, agriculture, result greenhouse gas also impact climate change like increase maximum and minimum temperature, high ocean temperature, increased precipitation, shrinking glacier, thawing permafrost, and rising water. Uh, and then, uh, and rising sea water level cause inundation and intrusion into land, so the lengthen high salinity. Currently, the saline area in Indonesia is estimated reach 600,000 hectare, and this number will increase due to the extreme climate. Lands that have the potential to be saline include tidal swamp, land along the coast, and dry land. Utilization of saline for agriculture related with land biophysical condition that do not support plant growth on soil that has electrical conductivity 3.5 millisecond per centimeter, rice plant will experience a decreased yield of 10%. This decline will further increase with increasing electrical conductivity value. Rice yield will decrease by 50% in soil condition with electrical conductivity 7.2 millisecond per centimeter. And then salinity affect yield and sustainable crop, nutrient availability, and microorganism activity. Based on the problem of based on the problem saline soil, so technology is needed for increase the productivity. And this paper is a review of result of researcher of research the improving rice production in soil saline. And then uh, we will discuss about saline soil. Saline soil is soil that contain high concentration of soluble salts such as sodium chloride, sodium sulfate, magnesium sulfate, sodium hydrogen carbonate, sodium carbonate, calcium sulfate, and calcium carbonate, so that inhibits plant growth. Based on the formation process, saline soil can be divided primary saline soil, secondary saline soil, and based on pH, AC, and ESP, saline soil were classified to saline soil, sodic soil, and saline sodic soil. The factors causing high salinity are soil parameterial, seawater intrusion, brackish water use in farming, restricted drainage develop into high water table, low rainfall, high evapotranspiration rate. And based on electrical conductivity, soil salinity is classified into 5 groups: non-saline, slightly saline, moderately saline, very saline, extremely saline. Amount of salt dissolved in body of water is called the salinity. The salinity and soil element contained in saline soil can degrade the physical, chemical, and biological soil fertility. The level of damage caused by salinity depends on the the ion type and concentration, the kind and tolerance of plant and management system. And plant, the symptoms that arise are the reduced ability of plant to absorb water, the occurrence plasmolysis due to increased osmotic pressure, the occurrence of toxicity due to absorbing excess amount of the nutrient that make up salt. The condition of salinity stress, sodium ion often have toxic effect on plant. The accumulation of sodium ion under saline condition suppress the absorption of sodium, natrium, and magnesium. It causes impaired chlorophyll formation, slow photosynthesis, trigger photooxidative reaction that damage the chloroplast thylakoid membrane. Okay. Okay, and then the management of saline soil. In saline soil, to get high productivity must be based on environmental condition and hydrology in situ. Such as the leaching, use rainwater or irrigation water cause salinity reduction. It will be optimal if it is supported by high rainfall, coarse soil texture, and good drainage. The second choice, by amelioration, example, gypsum and farmyard manure also effective for salinity reduction. And also importantly, utilization of adaptive variety and set of the time planting. This technology is a good alternative because this is the response of rice to salinity depends on the states of growth and development. And in the early vegetative and late generative phase, the rice is sensitive to salinity. So proper the land management and crop cultivation system are needed to achieve optimal production level. And then rice variety have different production in because the rice have the different ability of adaptation in salinity, so in salinity condition. From the table 3 show that farmyard and poultry manure increase of rice yield. It was related with K per sodium ratio and nutrient uptake. Okay. Based based the discussed earlier, we can conclude that climate change has the potential to increase saline area, the production of rice in saline soil low because high of an ion under saline conditions, so suppress the absorption of nitrogen and magnesium. Ability of plant to absorb water decrease. High of EC can cause the osmotic pressure, the water to increase, resulting in plasmolysis. And the last technology for increasing rice production in saline soil, including leaching, amelioration, use adaptive variety, and set time blending. This is a reference we use to write this paper. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. I think this is already this final presentation. So, however, this very interest presentation for how to manage the saline soil seems like that. So, I asking to the participant. We have still 5 minutes because this already the time is already 18, 18 and 34. Yeah, 18, 16, 16, 18. 18.34 in Bali and also 19.34 in Jayapura. But here is still 17.34. So we have 5 minutes for discuss. If you have any question, please raise your hand. Okay, Budia.
Okay.
Yes. Okay, Budia. First, Budia.
Okay.
Please
Thank you,
directly. You. Yeah.
Okay. For the time, I want to try to ask to presenter. According to your research, I want to ask which one of the technology to reduce the salinity soil that can improve or enhance the productivity of the rice. And then what is the important factor that influence the productivity of rice in saline soil? Okay, thank you. I think this is enough for my question. Thank you.
Yes, please. Answer directly, please. Bu Yuli Lestari, do you?
Okay, okay. I will to answer to question for Ibu Dia. Many technology to increase productivity, rice productivity in saline soil, like the leaching, amelioration, or utilization adaptivity, variety, and set of the time. The leaching can decrease element cause the toxicity, influence the salinity. So the condition of the soil better. Amelioration can amelioration like Gibson, it can reduce salinity also, and utilization of adaptive variety and set of the time planting, also the technology alternative can use to increase productivity, rice productivity in saline soil. The factor inherent influence the productivity, rice productivity in saline soil. I think especially the variety of rice important in rice cultivation in saline soil. There's easy choice and maybe not expensive. I think this. Thank you very much.
Thank you. For it is any feedback from Ibu
Okay,
Dia?
thank you. But I think in Indonesia, I think about the salinity tolerance rice cultivar is still limited. So I think and also we sometimes we difficult to obtain this rice seed. So I think the breeding of the rice to produce saline tolerance, saline resistant rice is very important. Thank you. I think it's enough for your response. Thank you.
I saw Ibu Zainab already raise hand. Do you want to asking? Yeah, please.
Yes.
At the time, sure.
There are three management of saline soil:
yes.
leaching, amelioration, and
Amelioration and
adaptive
adaptive
variety.
variety. Yes.
What is the most improved to rice production, and which is the most adaptive rice variety? Thank you.
I think okay. Thank you, Ibu Zainab. I think we use three technology together to get a high product, high yield of the rice. I think use three technology like the leaching, amelioration, and utilization of adaptive variety together. I think get a high yield of rice in soil salinity. Thank you.
Okay, I think is discussion about salinity is very important because in the case of Java, in the north area of Java, usually many of intrusions from water from sea, so remain the many salt in the land, so decrease the production. As for example, production of onion in Brebes seems like that they decrease because of seawater intrusion and then become saline soil conditions. This is the case in Java. Out of Java, I think similar because in some swampland, pasang surut land seems like that. This is very important to solve in, but maybe sometime people person already confused how make different how to understand different between saline soil and sodic soil, because actually this seems similar saline, but the constraint is different. If the saline soil, the constraint is in this concentration of salt, but the sodic soil, the most problem is natrium. Seems like that. So this different kind and different technology, different approachment seems like that. But I agree also with Ibu Dia, but improvement variety and also molecular biological molecular to improve the tolerance of rice. This is very important in the future. Seems like that. So I think this already enough. I think because already Maghrib here, and thank you very much. So Mr. Ari, I will send back moderator to Bapak Dwi Priyo Arianto. So actually I am participant, but he wanting me become exercise, become moderator. So I already become moderator. I'm very sorry because my speak is not sometimes my very little bit ngocol seems like that. So I'm so sorry. Thank you, and happy. Very sorry if any some unpolite talking things like that. So because actually I just want friendship for you all. Thank you. I send back to Mr. Dwi Priyo Arianto because he want to make announcement the best presentation. But I don't want. He said that the president is me. I don't want like that. So I will the others people. Okay. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mr. Rahayu, not Mrs. Rahayu, but Mr. Rahayu. Before I closing this session, I will announce best presenter from more than 10 presenters. The best presenters in this session is Mrs. Diah Rahmawati. Please applause for Mrs. Diah Rahmawati for the best presenter, and we will send the certificate for best presenter beside the S presenter in this session. Okay, maybe we enough from this session. Oh, maybe any statement?
Selamat buat Budia, selamat Budia.
Okay, congratulations to Mrs. Tia. And
dia sudah siap statement.
Budia, any statement?
No, I think it's enough because I think
Okay, thank you, Budia. And as moderator, I will thank you for all participant and presenter in this session. And I hope we can see next year. And I'm sorry if I have a mistake or my English not so good. And thank you very much. Wabil taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Goodbye. See you next time.
I think tomorrow schedule. Tomorrow it is already finished in this day.
Yes, for tomorrow we compress in only one day, so only in 2 days, only this day. Okay, thank you.